Hi everyone, welcome to Triple Bench. I am Archana from Kerala. This is my first video in this YouTube channel. In this channel, today I am going to discuss you a very important topic on control system, which is our body plot. For explaining body plot, I am using my own teaching methodology. I used to explain all the procedure step by step by using with the help of an numerical. Anyway, I'll write one question regarding BODE plot in this board and I'll explain it. Shall we start? Come with me. So guys, here I write the question as sketch the BODE plot of the following trans function. Determine the system gain k, here the constant k, for the gain crossover frequency to be 5 radians per second. I didn't explain what is frequency domain response, what is the frequency domain specification, what is time domain specification and time domain response. Anything, I'll do it. All the videos will come so fast. And here, the given in this question, the given data is the upper loop transfer function, that is g of s is equal to k square divided by 1 plus 0.2 s into 1 plus 0.02 s. As you all know, the BODE plot is in the frequency domain response, or it is in the frequency domain system. So for frequency domain system, here the question open loop trans function is in the S domain. So we have to convert this S domain to the frequency domain, right? We have to convert this S domain to the frequency domain. For that, for converting S domain to frequency domain, just assign S is equal to j omega. Okay, just assign s is equal to j omega. Here, g of s is equal to k square into 1 plus 0.02 s into 1 plus 0.02 s, right? In this question, for converting this open loop transfer function to the frequency domain system, we have to substitute j omega in terms of s. That is, g of j omega is equal to k into j omega the whole square divided by 1 plus 0.2 j omega into 1 plus 0.02 j omega. Here we convert this system to the frequency domain. Then, what is BODE plot? Basically, BODE plot can be classified into two types of plots as the magnitude plot and the phase plot. So, what is magnitude plot? Magnitude means what? Magnitude is a kind of magnitude is a kind of gain or a prominent value, right? Or a prominent value or a distinct value is magnitude. So from this, it is clear that we have to find the magnitude of this system, right? We have to find the magnitude of this system. That is the magnitude plot. Then in the case of phase plot, phase means what? An angle or an inclination is phase, right? So in the case of phase plot, we have to find out some of the angles or the inclination regarding this system and then plot it versus the phase angle versus the log omega. Okay? So the first step in this system is, here we have g of j omega is equal to k into j omega the whole square divided by 1 plus 0.2 j omega into 1 plus 0.02 j omega. It is clear that one constant called k is here, right? So we are not able to proceed the next step having this k. For that reason, we are assigning the k, constant k is equal to 1 or as unity. Assign or assume the constant k is equal to 1. Assume k is equal to 1, then g of j omega tends to what? J omega the whole square divided by 1 plus 0.2 j omega into 1 plus 0.02 j omega. Okay, 1 plus 0.2 j omega into 1 plus 0.02 j omega. Then you can write the first term as magnitude plot. Here we start the procedure for magnitude plot for erasing this question and write this Opperloop function in this side. Then write the procedure. Okay, you want to write all this. So guys, for finding the magnitude plot, we have to find the corner frequency. Corner frequency is simply defined as the meeting point of the frequency at which the meeting point of two asymptote. Okay, the frequency at which the meeting point of two asymptotes is called the corner frequency. But for finding the value of corner frequency, we are using the old equation called frequency is the reciprocal of time period, right? Frequency is the reciprocal of time period. Then what is the time period in this system? Okay, what is the time period in this system? Here, it's simply saying that we have the system g of s. I would take this g of s. G of s is s square divided by 1 plus 0.2 s into 1 plus 0.2 s. It's only 0.02 s. It's only, we get this equation by assigning k is equal to 1. Okay. Then, what is the time period here, right? That be our question. So, for finding the time period, here just check this equation 1 plus 0.2 yes. And here it is 1 plus 0.02 yes. 1 plus 0.02 yes means what's the coefficient given with or coming with yes. The coefficient of s is it's 0.2 yes, right? 1 plus, guys, it's 1 plus 0.2 yes. So the coefficient of s is 0.2. This 0.2 is the time period. That means a system is defined as 1 plus st. Okay, 1 plus st be the equation. The general equation is 1 plus st. In this, the coefficient of s is t. This t represented as the time period. And here, comparing this equation, these two equations, we get the time period as 0.2. Clear? Comparing these two equations, we get the time period as 0.2. So, taking the first, for corner frequency, we represented it as omega c. For we have how many corner frequencies in this question? 2 corner frequencies. How would it get? The two equations called 1 plus st, 1 plus st. That means we have two terms, 1 plus st1 plus st1 and 1 plus st2. I can say it as 1 plus st1 and 1 plus st2. So from this, I assigned the first is omega c1 be the first corner frequency. That means 1 by t1, and the second corner frequency which would be the 1 by t2. So, what is 1 by t1? What is 1 by t1? It's the 1 by t1 is the terms are 1 plus 0.2 s and 1 plus 0.02 s, right? 1 plus 0.2 s and 1 plus 0.02 s, or in the frequency domain we can write it as 0.2 j omega and it is 1 plus 0.02 j omega, right? 1 plus 0.02 j omega. From this, we get the first corner frequency as 1 divided by 0.2. The first term is 1 plus 0.2, yes. So, the first corner frequency would be 1 by 0.2 and the second corner frequency would be 1 by 0.02. Yeah, 1 by 0.02. So, 1 by 0.2 means 5 radians per second. 5 radians per second be the first corner frequency and the second corner frequency 1 by 0.02. 1 by 0.02 by calculating it would get as 50 radians per second. Okay. Next thing is, so here we find the corner frequency for finding the magnitude plot. It's always for finding the magnitude plot and not for the phase plot. So the next step, the step 1 is over and the next step number 2 or the next step is you have to draw one tabular column. Anyway, write all these guys. I'll explain the next one. I drawn the tabular column and noted it as the first term is term, the first column is term, second is corner frequency, third is slope and change in slope. We know the terms and the corner frequency, but we didn't know the slope and the change in slope, right? First, you have to write the terms and the corner frequency regarding that terms. First, here our question is, or the frequency domain's response system is g of j omega, or the open loop system is g of j omega is equal to j omega the whole square divided by 1 plus 0.2 j omega into 1 plus 0.02 j omega. The first term would be the numerator term. It should be j omega the whole square. Okay, j omega the whole square. The second term and the third term is in the denominator. So we need to put it like that. Then 1 by 1 plus 0.2 j omega and 1 by 1 plus 0.02 j omega. Here it is 0.2 j omega, and the third one is 1 by 1 plus 0.02, that is not 2 j omega. Then close the tabular column. We have only three terms. Then the corner frequency for the first term. We didn't have corner frequency for the first term because it's standard for finding the corner frequency. The standard term is like 1 plus st, right? 1 plus st. We have the first term is j omega the whole square or the s square. So that term wouldn't have any corner frequency. So we can assign a dash here. Then the second one is 1 divided by 1 plus 0.2 j omega. It should have the corner frequency, and we found out that omega z1 1 by t1, that is 5 radians per second. So I write it as 5 radians per second. 5 radians per second, and the second term is 50 radians per second. Sorry, the third term is 50 radians per second. Yeah, 50 radians per second. Then the third column is the slope. I didn't explain any idea about slope. So what is slope and the general conditions for finding the magnitude plot? The general equation for find out a magnitude plot or for finding a gain, the general standard equation is, or the gain equation is 20 log j omega. Okay, it's 20 log j omega. And for finding the value k, here we have one k in the question. K is square divided by 1 plus 0.2s into 0.02s, 1 plus 0.02s. For finding the value of k, we assign this general equation, or we convert the standard equation to 20 log k. Okay, 20 log k. Then if k is equal to 1, log k, log 1 is equal to 0, then it's 0, completely remains 0. In this case, we take the slope of j omega is 20. Okay, in decibel magnitude, we find the magnitudes in decibels, and the slope of one system, or you just by heart this value for finding the magnitude j omega is equal to 20. So for finding the slope of j omega squared, you need to multiply 20 into 20. No, not at all. For finding the slope value, in the case of magnitude plot, here we have s square or j omega square. That means we need to multiply j omega the whole square. Can you see? Spacing issue. Can you see it? J omega square is equal to j omega into j omega be the meaning of square, right? J omega square is equal to j omega into j omega. But here we didn't go for the multiplication, and we go for the addition. Okay, we go for the addition. So 20 plus 20, for asking for multiplication in the case of magnitude plot, you need to go for addition. That is 20 into 20. You need to do it like this. 20 plus 20, that means the slope would be 40. Yeah, the slope would be 40. Then the next slope or the next term is 1 divided by 1 plus 0.2 j omega. Here we have 1 j omega, single 1 j omega. The value of j omega, magnitude value of j omega is what? 20. Here it is 1 by j omega, or this j omega is in the denominator term. So denominator term carrying with a j, an imaginary. Okay, so 1 by j means what? Guys, 1 by j is minus j. Imaginary term 1 by j is minus j. So 1 by 20 in the denominator, it goes to, when it goes to the numerator, we get it as minus 20. Okay, we get it as minus 20. And here also in the third term also we have j omega in the denominator, and it should be the single j omega, one value, magnitude of j omega is 20, it's always in the denominator term, so we go for minus 20. Then the fourth column is change in slope. Okay, third column is change in slope. How to find the change in slope? Always you need to compare a slope with the upper value or the higher than upper value. Okay, you need to compare the slope with the upper value. In the first term, j omega square be the first term, so it shouldn't have any higher value or the upper value. It shouldn't have any upper value. So we didn't find the change in slope for the first term. For the second term, we need to compare the slope with the first term, right? Compare the slope with the first term to find the change in slope. So we did it like 40, this 40, okay, plus minus 20. That is 40 minus 20 as 20. Okay. Then next term we found out like this 20 plus this minus 20. That is 20 minus 20 is what? 0. Okay? 0. This is the change in slope. You all understand? You all understand this? First term, we didn't have any upper term or the higher term. Not the higher term, upper term. We didn't have any upper terms. Here we have the first term called j omega square, it's 40. It shouldn't have any change in slope. Then the second term should have the change in slope. Why? Because of it? It's only because of the second term should have the first term. Yes, right. The second term should have an upper term be the first term, that then we can compare it, these two slope values, we get it as 20. Then for finding the third change in slope, we have to compare it with the change in slope of the second term with the slope of the third term, then we get it as 0. Okay, so the steps for magnitude, so in the case of magnitude plot, we completed the corner frequency and the tabular column. Clear? We completed the corner frequency and the tabular column. Then the last step, it should be the gain. For finding the gain, we have to assign some more corner frequencies or frequency. It's for, I said earlier that magnitude plot is drawn by using the magnitude values versus the log omega values. Log omega values means the frequency values. Here we have only two frequencies called the first corner frequency and the second corner frequency. So we should have only two values, right? So for finding or for plotting this graph, we assume two more values. More values means first you have to take the lowest value in the corner frequency. It should be omega c1 is equal to 5 radians per second be the our lowest value, and the 50 radians per second be the highest value compared to the corner frequency. And you have to consider the value lesser than the first corner frequency or than the lowest corner frequency. The lowest corner frequency is 5 radians per second. So you have to assign or you can choose any values lower than the lowest corner frequency. Okay, lower than the lowest corner frequency. The lowest corner frequency is 5 radians per second. So I choose the first lower value as I choose the first lower value as omega L, which is 5, the lowest value is 5, so I choose it as 0.5. Okay, I choose it as 0.5 radians per second. And the next value we have to choose The next value we have to choose is the higher value, the highest value than the upper corner frequency. Upper corner frequency or the highest corner frequency here it is 50 radians per second. So you need to choose one value higher than the highest corner frequency. Highest corner frequency is 50. So I can choose it as 100. You can choose any value. If you want to choose it as 80, you take it. No issues at all. You take it 80, 70, 60. All those are values higher than 50. Right? All those are higher than 50. But here I choose it as 100. Okay. I choose it as 100. Clear? So we have the 4 corner frequencies, tabular column. The next step is to find the gain. So guys, the next step and the last step be to find the gain. Let's assign gain as A. Okay. For finding the gain, we have 4 frequency values called the omega L, omega H, omega Z1 and the omega C2. First, how to find the gain? The 0.5 the whole square. Then you think how we get it as 0.5 the whole square. The first term is j omega square, that is 20 log g of j omega be the standard equation, but you need to substitute the first term in the case of or in the side of log of g omega for finding the gain. Okay, in this question we have the first term is g of j omega, so I substitute 20 log g of j omega instead of I substitute 20 log g of j omega the whole square instead of 20 log g of j omega. 20 log g of j omega be the standard equation or the standardization equation. But we have to find the gains for the given question. Okay, the given question. For that, we need to substitute the first term in the tabular column to find the gain. That is A is equal to 20 log g of j omega the whole square. This g of j omega, you just substitute the corner frequency value, it's 0.5 the whole square. Okay, then take your calculator and multiply and find out simply. I get it as minus 12 dB. The unit of magnitude or the gain is decibel, that is dB, minus 12 dB. Then the next one, next gain is A is equal to what? We need to substitute A is equal to, in the order, you need to substitute the frequencies values in the ascending order. So A is equal to, at the next, omega is equal to omega C1, which is 5 radians per second. 5 radians per second, that is 20 log 5 square, which is, and the third gain, you need to check the tabular column also. I'll explain why, because to find A, omega is equal to omega C2, right? Omega C2, which is, we get it as 50 radians per second. Okay, 50, I write it as 50. For finding the third gain, you need to check. I said you need to check the tabular column. It's 4 or it's biggest of from the tabular column. In the tabular column, the second term, we should have some change in slope, right? We should have some value of change in slope, a specific value of change in slope. So you need to substitute this change in slope here to find the gain. So the equation changes, and here we use the general standard equation 20 log of g of j omega. Instead of g of j omega, we substitute the first term, right? The first term in the question of log trans function. For finding the from the in all the questions of BODE plot, the third slope to find the gain. In the third section, the third value, whichever value you substitute, for finding the gain, you need to substitute the change in slope. Okay, you need to substitute the change in slope. For that, the equation changes. This slope happens from where to where? Okay, this slope happens from this set, first step to the second. That means we wrote it as gain A is equal to what is A is equal to omega is equal to omega C to 50 radians per second. For that, we wrote the equation be like slope from slope from which one to which one? Omega C1 to omega C2, right? The slope, this slope happens from omega C1 to omega C2. Corner frequencies, the omega C1, the 5 radians per second to 50 radians per second is compared as the change in slope, the third change in slope. So slope from omega C1 to omega C2, this gain to this, the change in slope happens from the omega C1 to omega C2, right? That is slope from omega C1 to omega C2 into log omega C2 divided by omega C1 plus the gain at which omega is equal to omega C1. The value next behind the omega C2. The value next behind the omega C2 is omega C1, right? That is omega is equal to omega C1. Omega is equal to omega C1. That is slope from omega C1 to omega C2 is 20 into log omega C2. Omega C2 means what? Log of omega C2. That is 50 divided by omega C1 is 5 plus a gain at which omega is equal to omega C1. Gain at which, it's actually my mistake. So it's gonna be 48 dB. 48 dB. Then the third slope equation or the gain value is A is equal to 48 dB. Then the last one, we didn't have the change slope. We have the change in slope is it's 0, right? 0. So we write the equation from slope from omega C2. This is omega C2. So the fourth equation tends to slope from omega C2 to omega h into log omega h by omega C2 plus gain at which omega is equal to omega C2. From this, omega C2 slope from omega C2 to omega C1 is 0 into any value is again 0 plus gain at which omega is equal to omega C2, which is 48 dB. So the fourth term is always similar as the third term. I completed. I think you all understand this. Then we have all the gain values and the frequencies values. Then we are ready to draw the magnitude plot. Shall we draw? Actually, I had drawn it already, but you don't worry. I'll explain it neatly. Drawing our magnitude plot, you need to take the log omega values and the magnitude values or the gain values. In the semi-log graph, we already have that log omega values or the frequencies values here. And in the left side, I take all the gain value. Our gain values are in the range of starting from minus 12 dB and ending at 48 dB, right? Okay. For in the case of semi-log graph, we have the values for the first ones. Can you see this? For the first ones, it's all these are the decimals value. Then ones, then tens, then hundreds, thousands, like that. It's going on like that. So, firstly, we have the value called the 0.5 or corner frequency values or the frequency omega values are 0.5. Then it's 5, then 50, and the last one is 100. For 0.5, we get our gain as minus 12 dB. So here minus 12 lies in between minus 10 and minus 20. So from 0.5, 0.5 is the value corresponding to 5 is 0.5. Okay, it's the decimal points. Then corresponding 5 to minus 12, here it is 1. Then the next one is 5. The angle 5 corresponding to the gain value is minus 28 dB. Again, it's minus 28 dB. Then for 50, it's 48 dB. And for 100, it's 48 dB. Then I'll join all these points. This be our magnitude plot. Clear?